What up, calculus students? Excuse me. New homework on the chain rule, um, where we see composition, where there's like an outside and an inside. And to take the derivative of this composition, we use the O's and the I's to help us. The chain rule is you identify an outer function and an inner function. You take the derivative of both of those pieces. The product of the derivative of the composed functions is the derivative of this function. Um, Multiplying things together, if you'd like to, you can multiply certain constants by constants. You can move the x squareds to be up with the 12. You can multiply the 12 and the 6 and get 72x squareds. And then the other key concept is what starts in the parentheses stays in the parentheses, like Vegas or the locker room. This is the derivative. This is the chain rule. And what's nice about the chain rule is that it leaves things in a factored form. So if you need to set this equal to 0, you can. It's not that bad. Now, I give you this example first and then immediately go to, a tougher example. Why? This is a number 3. We can consider the number 3 as just being a constant that we don't worry about when we're taking the derivative. Like 3f of x's derivative is 3f prime. 3 sine x's derivative is 3 cosine. 3x squared's derivative is 3 times 6x. 3 times 2x, which is 6x. This is not a number times a function. What we have are x's times x's. So I throw this at you right off the bat, just so you're aware, hey, if you see x's times x's, you got to use the product rule. Now, the product rule is tricky here. You got the derivative of the first, great, times the second, slopes of the first times the second, plus we have to use the chain rule to find the slopes of the second. So for the slopes of the second, I need an OI, and I just did that over here. So here are the slopes of the second. Actually, why don't we do it again, because we don't have this 3 here, so I'm not going to have the 12. We'll just do the parentheses to the fourth is the outside, and then the 2x cubed plus 1 is the inside. 4 stuff cubed, and then 6x squared. I'd get 24x squareds times 2x cubed plus 1 cubed. That's the slopes of the second. Don't forget to multiply by the first. This is fine if I asked you to find the slope of this function at 1 or 2 or 0 or any value. You could just plug it in here. Later in this lesson, we're going to work on setting this up to solve an equation, and we're going to talk about factoring this. But for right now, we'll leave it at that. Where we see a lot of chain rule is with trig functions. Now, what's important is if you ever see a power over a trig function, you should immediately rewrite it as a quantity to the power. Now, what's important is that the cube is over the sign. It's not over the 6. So this would be rewritten as 6 quantity sine x cubed. That's h of x. Now I can identify the O and I. It's just the number 6. It's not x's, so we don't need the product rule. And the inside sine x's derivative is cos x. If you'd like to rewrite it so that the cos x and the 18 are kind of together up front, that's fine. What starts in the parentheses stays in the parentheses. Sine x started in the parentheses. Sine x stays in the parentheses. If you're looking at a multiple choice question, you're probably going to see that where they move the square over the sign. Now here, we see the parentheses, and the outside is the 6 and the sine. Now, this is different from a lot of the examples we did in class. We did a couple like this. If your outside is a trig function, that's fine. The derivative, and again, the 6 is not bothering anything. It's not x's. You don't need the product rule. The derivative would be 6 times the derivative of sine, which is cosine. The derivative of x cubed, 3x squared. If you'd like to multiply the 3 and the x squareds together, do that. It's good to show this step that we're multiplying the derivatives of the composed functions. So j prime is 18x squared times cosine parentheses. What starts in the parentheses stays in the parentheses. Okay. This one is a good one. It's a tricky one. You do identify an O and an I. I could actually simplify this to start, but let's just go off of this. And let's see what happens and how we can simplify this. You have one of these on your test, and simplification is important. The derivative of the outside, easily done. 4 stuff cubed is the derivative of stuff to the 4th. The derivative of the inside, you have to use the quotient rule. X's divided by x's. Let's remember the quotient rule. It's the slopes of the top times the bottom minus the slopes of the bottom times the top, all over the bottom squared. I'm probably going to simplify this just to help myself out. I have 2x squared minus 2x minus x squared. So that's going to be 1x squared minus 2x. So k prime is 4 stuff cubed times x squared minus 2x, which can be factored to be x times x minus 2. We'll see if we need to do that, over x minus 1 squared. Now, what starts in the parentheses stays in the parentheses. I want you to see something that can be done here. And we could have done this to start if we wanted to. We could have distributed this 4 and made this x to the 8th and x minus 1 to the 4th. I'm going to distribute the cube. Now, biggest thing that students make mistakes is x minus 1 cubed is not x cubed minus 1. That's wrong. You have to do x minus 1 times x minus 1 times x minus 1. So watch what's going to happen. I'm going to distribute and just like x squared minus x squared over x minus 1 cubed, multiply by itself 3 times. I get x to the 6 over x minus 1 cubed. And then I am going to factor this for fun because I think it'll make it easier when I simplify it. And I'm going to combine all of my fractions, including the 4, giving me 4x to the 7th times x minus 2 over x minus 1 to the 5th. This is kind of what's expected for a test question that you're going to see, where we have this quotient rule inside the chain rule, this kind of distribution and simplification. Don't think that because you get this and you don't see that answer that you're wrong. Just like keep working. All right. Just reminding you of your other trig derivatives and another example of heads up, x's times x's. We got to use the product rule first, and then inside the product rule, we'll use the chain rule. So I'm not going to O and I it. I'm instead going to take the slopes of the first times the second. Plus, now I'm going to slopes of the second. I got secant parentheses and 2x. A lot of people don't realize that this is a chain, and a lot of the examples that I did not have this simple one, but I have a couple later. The slopes of 2x are 2, so the derivative of 2x is 2. The derivative of secant is secant parentheses tangent parentheses. You will have to know that for your test. So the slopes of the second are secant parentheses tangent parentheses times 2. What starts in the parentheses stays in the parentheses. That's the slopes of the second. Don't forget to multiply by the first. If you'd like to factor, you can. I'm actually fine with this. Maybe put the 2x in front. You could factor out a secant 2x if you wanted to. Maybe you have to do that, but I don't think it's going to help us. All right. The next four are OMIs. What we notice is, especially for this first one, if you see a power over a trig function, you should immediately rewrite it as your trig function all to that power. We see two sets of parentheses, which means we have an outside and a middle and an inside. The chain rule works though. However many composed functions you have, just take the derivatives of them and multiply them together. And there you have it. You have a cube, a sine, and 3x squared minus pi. Now, why did I give you 3x squared minus pi? Because a lot of people think the pi is like a variable and its derivative is, I don't know, pi, or it's a number, but like pi is just a number. So the derivative is 0. So the derivative of the innermost piece is 6x. The derivative of the middle piece is cos parentheses. And the derivative of the outer piece is 3 parentheses squared. It's no big deal. The only thing that might be tricky is the whole what starts in parentheses stays in parentheses. Oh, and you know what? When we multiply all these together, I'm going to pause and just like do a better job of simplifying as we go. You're multiplying this by this by this by this. I can multiply the 6x and the 3 right off the bat. It will be easier to look at / we don't have to worry about as much if you just take care of that. So I just have 18x parentheses squared cosine parentheses. Now here's the key. What starts in the parentheses stays in the parentheses. What starts in the parentheses stays in the parentheses. So what starts in the yellow parentheses stays in the yellow parentheses. Sine 3x squared minus pi started inside the outer parentheses. In the middle set of parentheses, the sine 3x squared minus pi stays in there. And that's your derivative. Okay? It's just like this technique that we just got to know, and it's not that tricky once you kind of embrace the parentheses and the O's and the I's. I don't think it's that bad. The way I used to teach it was bad. First thing I'm doing is rewriting this as a 1/2 power, identifying the O and the M and the I. Why am I knowing OMI? I see two sets of parentheses. There's a lot of drama going on outside. Cool. Derivatives of all of our composed pieces multiplied together. I'm probably going to multiply the 1/2, the -1, and the 3 together to give me 3 halves. What function is this? G. G prime is going to be -3 halves. I know a 1/2 power is going to go in the denominator. So I'm just going to like throw everything together so that it's already simplified. So I have -3 sine parentheses in the top over 2 root parentheses. Why did I get that? That's the same as like 1/2 to the 1/2. I'm writing that there. The -3 stays up. The sine stays up. I mean, this is just like good practice. Do you understand how to rewrite things, how to keep things simplified? Good practice for a test where multiple choice, you have to identify the correct derivative. What starts in the parentheses stays in the parentheses. 3x started in the cosine. Cosine 3x started in the 1/2. Okay, that would be simplified. Looking nice. Okay. First thing I do is write this as a cube. 2 sets of parentheses, outside middle, inside, cube, tan, pi x. Now, pi x's derivative is pi. It's just like the derivative of 5x is 5. Tangent's derivative, you need to know this for your test, is secant squared. 3 parentheses squared. Multiply these together. Let's try to simplify as we go. The 3 and the pi. Big parentheses squared. Secant squared, parentheses. What starts in the parentheses stays in the parentheses. What started in the cubed will stay in this big set of parentheses. That's the tangent pi x. What started in the tangent parentheses stays in the smaller parentheses. That's pi x. Okay, so it's not this goes in here and that goes in there. That's a big mistake. It's like multiply the things together. What starts in the parentheses stays. All right, last one. And then we get to move on. OMI squared secant 3x, 2 parentheses, secant parentheses, tangent parentheses, 3. The 3 and the 2 all multiply together to get 6. 6. Parentheses to the first, so big parentheses at secant 3x to the first. Then I have secant 3x, tangent 3x. If anything, you would be expected to understand that secant 3x times secant 3x is secant squared 3x. Cool. All of these was just practice for the chain rule. Now, make sure we know what to do with this. Make sure we understand that these derivatives are M equations. You plug in x's, you get m's, right? Don't forget that. Don't forget that if when you plug in x's into functions, you get y's. It's these derivative equations that produce m's. They're tangent slope generators. What is the purpose of finding the derivatives? So that we know the tangent slopes of the original function. So we know how the original function is changing, how quickly it's changing. Let's not forget that. This is why this page is here. So we remember, like, what do we do with these derivatives? This one is probably my favorite one. It's going to be on your test one just like this. A lot of people screw up on something like this. Now, what do we want to do first? We know we need a y minus a y1 equals an m times an x minus an x1. Why don't we find the y coordinate first? Plug in x into your function, into your original equation. You get a y location of your original equation. So the cosine of 5 pi over 6, 5 pi over 6 over there. Cosine adjacent is root 3 over 2. It's negative because I'm going to the left. Yeah, whatever. So negative 3 root 3 over 2. That is my point, pi over 6, negative 3 root 3 over 2. Now let's find the slope. Now, to find the slope, I see parentheses. I need to do an O and an I. This is probably the most important one because it seems so simple that you don't need it, but you do. 3 cosine parentheses. 5x is inside the parentheses. The derivative of 5x is 5. The derivative of 3 cosine is negative 3 sine. That means y prime, the slope equation, is negative 15 sine, not cosine. The 5 times the negative 3, negative 15 sine 5x. Cool. Slope equation, plug in x's, get m's. We are plugging in pi over 6, not 5 pi over 6. We will get 5 pi over 6. Get negative 15 sine 5 pi over 6. 5 pi over 6, again, to the left. Sine is the vertical. I'm going up just a little bit. It's the shorter 30, 60, 90 triangle. 1/2 is the smaller side. The vertical side is the smaller side. We get a half. That's positive. So we get negative 15 halves. This is an M. This is a Y. This is our X, right? It's just so important. Y minus plus 3 root 3 over 2 equals M x minus pi over 6. Cool. Let's find our y coordinate first. 3 minus 4 cubed is negative 1. 3 minus 4 cubed is negative 1. So there's my x. There's my y. Now let's find my m by getting my tangent equation. Since I have parentheses, I need to O and I it. Outer, inner, outer derivative, inner derivative. Multiply this together. Let's multiply the 3 and the negative 2x together. Negative 6x parentheses squared. What starts in the parentheses stays in the parentheses. Plug in 2. I get negative 12 times negative 1 squared, which is positive 1. So I get negative 12. That's an m. At 2, negative 1, my function is decreasing 12 y's per x. That's the power of a slope. We know exactly how quickly my function is changing at a location. Y plus 1 equals negative 12x minus 2. Next. Oh, what am I sticking with 5 pi over 6 for? I should have put in like 4. Damn. A minute. Finding the y coordinate right now. I already did this. The sine of 5 pi over 6 is 1/2. Okay, so that is my point x, y. Let's find my slope. I got an O and an I. I love looking at this one. This confuses a lot of students. What I'm going to do, so it makes sense, is think about it as being a coefficient of x, like 5x. The slope of 5x is 5. The slope of pi over 6x is pi over 6. Slopes of sine or cosine, here are the derivatives of my composed functions. Multiply them together, and I got this pi over 6 cos pi x over 6. Plugging in 5, I get pi over 6 times negative root 3 over 2. Yo, that's gross, but that's the slope. negative root 3 pi over 12. So I got y minus a half equals negative root 3 pi over 12, x minus 5. That's it. I could graph this and see the beautiful work that I've just done. Last one of this page, then we get harder. If I plug in negative 2, I get 4 minus 6 plus 5 cubed. Three cubed is 27. Great. There's my x and my y. Let's find my m. O, I. If you want to, you can multiply the 3 by the 2x plus 3. Now, the 2x plus 3 is in parentheses. I think a lot of us picked up on this pretty well. So you get 6x plus 9. It actually doesn't help you that much. Like if you were to set an equation equal to 0, or if you were to just plug in a value, it doesn't help you to have this distributed in. It can be. I like it when it's just one constant times one constant. So like here, I'd probably just write it as this. What starts in the parentheses stays in the parentheses. This is going to be a nice value. 3 times negative 4 plus 3 times, we already did this, but it's squared. So this is 4. Oh, I screwed up. No, 4 minus 6 plus 5, which is 3. 3 squared is 9. So I get 3, negative 1, 9, which is negative 27. Would you look at that? There's your m at negative 2, 27. So I got y plus 27. No, y minus 27. So my y coordinate equals my slope, x plus 2. Okay. A couple tricky ones where we have the product rule, and I'm going to ask you to find the horizontal tangents, which means we need to solve an equation, which means we're going to have to factor. We'll talk about that. And then we have these table problems. Okay, so these are tricky. You will have to do this on your test. Horizontal tangents when our slope is 0. Okay, so I want to figure out what are the equations for my slopes. When will my slopes equal 0? I see x's times x's. I need to use the product rule. Derivative of the first times the second. Plus, to find the derivative of the second, I need an o and an I. I have a 6 and an x squared minus 4. I get 6 stuff fifth. I get 2x. Multiply those together. I'll get 12x. What starts in the parentheses stays in the parentheses to the fifth. That's the derivative of the second piece times the first. Let's go ahead and multiply the 12x's and the x squareds together. You can't multiply in the x squared minus 4, that stuff in there because of the fifth power. So we got to leave the 2x outside. Cool. Now, to solve this equation set equal to 0, it helps to have things factored equal to 0. Here's how I'm going to help show you how we factor this. I'm going to replace x squared minus 4 with a variable. I don't want to confuse you by putting in y because this is not like a y coordinate. But I'm going to do it because I've done it before and it makes sense if you see it later. I'm going to replace x squared minus 4 just with a variable. It can be anything, and it's going to be y, and that's to the 6th power. I'm going to replace x squared minus 4 with y. So I still have 12x cubed. I'm going to replace x squared minus 4 with y. If I showed you this, I bet you could see that you can factor out a 2x and 5y's, leaving you with 1y and then 6x squared. Cool. The reason why we do this is because we can re-replace the y with what it's equal to. And notice that we now have our factored form. After doing a little bit of a simplification inside here, this x squared minus 4 is 7x squared minus 4. Cool. So I took the y, re-replaced it with x squared minus 4, x squared minus 4 plus 6x squared is 7x squared minus 4. Cool. Now that we have a product set equal to 0, we get our solutions. From our first piece, 2x, x could equal 0. From our second piece, x squared minus 4, x could equal positive or negative 2. And from our third piece, 7x squared minus 4, I add 4 divided by 7 square root. I got plus or minus root 4/7, or 2 over root 7, but this is fine. There we go. These are all the locations of my horizontal tangents. If I looked at that function, I'm just going to do it. Esmo slows down my computer, though. To the 6th. Okay. Well, you can see a horizontal tangent here at -2 and at +2. You can see a horizontal tangent here at 0. Let's shrink these x's to be like -3 to 3. Cool. Let's look up on my y's. Bam. Okay, so we got the -2, we got the 2, we got the 0, and then up here is this decimal -0.756, and up here is this decimal 0.756. And I bet you if you take the square root of 4 over 7, you get this 0.756. Isn't that really cool? Like, we really have a good understanding of certain characteristics of this function. In the future, next unit, we're going to be sketching functions like this. That's sweet. Yo, I might have just made a huge video and then it just deleted. I hope I can add this video to my previous video and smush them together. Anyways, I'm O&Ing. Am I depressed now? Multiply the 4 and the 2x together. All right, at least I know I'll stop here. Get 8x, x squared minus 3 cubed times x squared. I can multiply the x squared and the 8x together. If this was a y to the 4th plus 8x cubed y cubed, and again, I'm trying to find when these slopes equal 0, you can factor out a y cubed from both, giving you y plus 8x cubed. Y cubed is x squared minus 3 cubed. X squared minus 3 plus 8x squared is 9x squared minus 3. I'm going to skip this one. This is enough. I get x equals plus or minus root 3 from this one. And I get x equals plus or minus 3/9, which is 1/3 rooted. Let's move on. Okay. Table problems with the chain rule. What's very important to understand is that F parentheses G parentheses X is not a product. Remember from last lesson that F of X's derivative is F prime of X. You saw parentheses here, but you didn't have to O and I it. If you O'd and I'd it, it would just be a little bit unnecessary because you'd have F prime of parentheses times 1. Well, like F prime, what started in the parentheses stays in the parentheses times 1. It's not necessary. So like you see this guy. You think, oh, you have two sets of parentheses, OMI. But the fact that the inside is just X means you don't need to OMI it. I'll show you. OMI is how we handle this. This is not a product. 3F, G, and then X. The derivative is just 1. I don't need this I. Okay? It won't change anything. As long as you know that G of X's slopes are G prime of X, you're fine. Okay? Now, H prime will equal 3F prime parentheses times G prime of X. What starts in the parentheses stays in the parentheses. Cool. This is the notational derivative of the chain. Now, how do we work with this? H prime of 3 is 3 times F prime of G of 3 times G prime of 3. This is not a product again. We need to find G of 3 and then don't multiply by F prime of 3. Just like find F prime at that value. Let me show you. G prime of 3 is negative 2. Now we need to find F prime of negative 2. I can't. I didn't give you the table for it. So if I change this to negative 2, then you could do that. So let's do that, see if that works. G prime of, G of 3. Oh, never mind. Gosh, this is like screwing up a lot on these table problems. G of 3. G of 3 is 4. Okay, I can do this. G of 3 is 4. Okay, this is a 4. F prime of 4 is negative 4. G prime of 3 is negative 2. My answer is 3 times negative 4 times negative 2, which is 8 times 3, which is 24. I'm just hoping that I'm not having to do this video again, or I'm going to go into a dark place. All right. I don't have to OMI it. I can just OI, because f of x's derivative is just f prime of x. The fact that you have an outside and an inside here doesn't matter because the inside is just x. Whose derivative is just 1. So we don't need to do it. The derivative of 2g is 2g prime. Don't be worried about the constant. It's not x's times x's. J prime, therefore, is 2g prime parentheses times f prime parentheses. What starts in the parentheses stays in the parentheses. The f of x started in parentheses. Work inside out. J prime is 2g prime f of, we're plugging in 3, times f prime of 3. F of 3 is 2. F prime of 3 is negative 3. G prime of 2 is negative 1. So this is 6. Okay, these are good ones to do to notice that the outside might be the function whose derivative is that. Multiplied together, I'm going to say k prime is 4x f prime of x squared. Plug in 2, I get 8 times f prime of x squared. 2 squared is 4. F prime of 4 is negative 4. Negative 4 times 8 is negative 32. Hope I'm not making mistakes on these because I don't want to. Here, we see two sets of parentheses, but we don't need an OMI. If you did, it'll work out fine. It's just the I is f of x, whose derivative is f prime of x. The O is the parentheses squared, whose derivative is 2 parentheses to the first. So P prime is 2 times f prime of x. What starts in the parentheses stays in the parentheses. P prime of 2 is 2 times f of 2 times f prime of 2. F of 2 is 4. F prime of 2 is negative 2. So this is a 4 and this is a negative 2. So negative 16. All right. This guy is a good guy because we have this 1/2 power and then g of x, g prime of x, 1/2 stuff to the negative 1/2. You want to write down the derivative. I'd probably write g prime up top, root g, which starts in the parentheses on the bottom. I'm finding it at 3. G of 3 is 4. G prime of 3 is negative 2. I don't want to do this, but I'm gonna. It's one of those product rules, x's times x's. I don't think you ever see something this advanced, honestly. That's good. I'm not going to do the value. I'm just going to show you what the derivative is. Because I'm in a dark place right now. I really don't think things are saving, and I have to like redo my video. We'll find out. Derivative of the first times the second. Plus the derivative of the second. I have to O and I the second. I have f parentheses 2x. I have f prime parentheses times 2. What starts in the parentheses stays in the parentheses. Oh, I keep saying that I'm not going to do stuff, and then I end up doing stuff. I plug in 2, I get f of 4. I got 4 f prime of 4. This is q prime with 2 plugged in. F of 4 is 3. F prime of 4 is negative 4. Negative 13. All right, good. Just need an O and an I here. 3f g of x. If you OMI it, you'll be fine. Because g of x's derivative is g prime of x. So h prime is 3f parentheses g prime of x. What starts in the parentheses stays in the parentheses. Plugging in 1, I get 3f of g of 1 times g prime of 1. Okay, g prime, slopes of g at 1 is fortunately 1. I don't like how that value is 1. I'd rather it be negative 1 or something else, so change things. G of 1 is 1, 2, 3, 4. So this becomes, f prime. This becomes f prime of 1, 2, 3, 4. F prime of 4, 1, 2, 3, 4 is the slope of f. Slope of f is positive 2. Up 2 over 1, the slope of that line segment is 2. So I think the answer is 6 to that one. The next question has to be an OMI because f of 2x's derivative is not f prime of 2x. There is an O and an I here where the derivative of the I is not 1. O, M, I, G parentheses, F parentheses, 2x. 2, F prime, G prime. Okay, so I get G prime of F of 2x, what started in the parentheses stays in the parentheses. F prime of 2x times 2. Plugging in 1, I get G prime of F of 2 times F prime of 2 times 2. Shit. I'm plugging in 2. Sorry. All right, so if I plug in 2, that should be a 4, and that should be a 4. G prime of F of 4 times F prime of 4 times 2. F is the black one of 4. 1, 2, 3, 4. 1, 2, 3 is 3. F of 4 is 3. G prime of 3. F prime of 4 we found was positive 2. The slope of this line segment is 2. That's the slope of the tangent. G prime of 3, 1, 2, 3. Slopes of G down 1, 2, 3 over 1. Negative 3 times 2 times 2 is 4, negative 12. All right, last two. O and I, G, x squared, 2x, G prime. Z prime is G prime of x squared times 2x. Plugging in negative 2, Z prime is G prime of 4 times negative 4. The slope of G at 4, 1, 2, 3, 4 is this negative 3. So positive 12. Here, you might see two sets of parentheses, but you don't need them. The outside is the cube. The inside is the g of x. The derivative of g of x is g prime of x. The derivative of the cube is 3 stuff squared. 3, what starts in the parentheses stays in the parentheses. That's a g prime. Yo, I'm just like praying right now that I don't have to re-record this video, at least the first half of this video. G of 3, 1, 2, 3 is 2. That's the red line. 3 times 2 squared times G prime of 3, 1, 2, 3 is the slope negative 3. So negative 9 times 4 is negative 36. All right, good luck out there to myself, who hopes that there are 2 videos out there which can be combined into one video that can be posted.